Hello students. In this video we are going to be finishing up some of the notes for A-14 that we did in class today because we didn't quite finish it. So this is the sheet that you're going to be looking at, the one that's properties of logarithms. And by the way, if I didn't mention it in class, this is actually sections H, I, and J. So we're going to, it froze, I'm not sure why. So I'm going to go back here. There we go. Okay, so we're going to go down to this page right here, all right, because these are the ones that I didn't get a chance to finish in class. So we're going to look at example 10 in this video. We'll do a second video for example 11, and then we'll do a third video for the ones that are on the back. All right, so in this problem, it says we're going to let x equal log of 2. Why? Well, because whoever wrote this problem decided that they were going to let x equal log of 2. And they're going to let y equal log of 6. And then it says write each of these expressions, so we have a number of expressions here, in terms of x and y. So all your final answers are supposed to be in terms of x and y. So remember that what we have to do with this is we're going to take these numbers, the 2, the 6, and then also a 10 is a possibility because this is log base 10, and you'll see in a minute how that works. And we have to think about rewriting all of these numbers, so you have to be a little bit clever sometimes, in terms of 2, 6, or 10, and then this number also, right? So the 12, hopefully you can see easily that that is 6 times 2. So I can think of this first problem as being the log of 6 times 2, or 2 times 6. And now what I have is a log of a product. And remember right here, this is the rule that tells you how you handle the log of a product, and that turns into the sum of the logs. So this is going to turn into log 2 plus log 6. Now the answer is supposed to be in terms of x and y, so you go back here and you say, well, log 2, not sure why that's freezing, log 2 is equal to x. So right here we can see x is equal to log 2, so this is going to become x plus, and then log 6 is equal to y, so x plus y is your final answer for that one. For B, hopefully you can see that that one, I'm going to go over here, is log of 3, and 3 can be found by doing 6 divided by 2, so log of 6 divided by 2. Now we know that we have the log of a quotient, and here's the rule for the log of a quotient. It turns into the difference of the two logs. It's the log of the numerator minus the log of the denominator. So this becomes log 6 minus log 2. All right, log 6 we know is y. Log 2 we know is x. So y minus x is what we're left with on that one. For C, for this one, and I would encourage you at any point, if you want to try these problems on your own, just turn off the video and try it, and then you can turn it back on and watch me go through it. So 48 is 6 times 8. Here's the 6, and then 8 is 2 to the third, isn't it? So this we can actually rewrite as the log of 6 times 2 to the third. Again, you can double check and make sure that that gives you 48. So now I have the log of a product, and here's the rule right here. So the log of the product becomes the sum of the logs. So it becomes log of 6 plus log of 2 to the third. Excuse me. And so now right here, notice that we have a log of a power. And this is the rule for the log of a power. You just bring that exponent out in front. So this is going to become, bring the 3 out here. So this is going to become log of 6 plus 3 log 2. Now, that would be the correct answer, but they ask you to write it in terms of x and y, and we know that log 6 is y, so that turns into y plus 3 times, and then log 2 is x, so y plus 3x. The next one, what you need to recognize is that 6 is, or the square root of 6 is 6 to the 1/2. Right? Then I'm using this rule backwards right here. Well, no, I guess I'm using it the same way I did here. So I have the log of a power, and when you have the log of a power, you can bring that exponent out in front. So this becomes 1/2 log of 6, and the log of 6 we know is y, so it becomes 1/2 y. Excuse me. The next one we can think of as being the log of 1 over 2 to the 4th. Remember, we're trying to use 2's, 4's, and 10's. So you could rewrite this as It's the log of a quotient, so you can write that as the difference of the logs. That's using this rule right here. So this becomes the log of 1 minus the log of 2 to the 4th. The log of 1 is just 0. That was one of our properties from the first page. And then this one I can bring the 4 in front, so I get minus 4 log of 2, which is just 4 log 2, negative 4 log 2. And then what we want to do is rewrite it in terms of x and y. So remember, log 2 is equal to x, so this becomes negative 4x. Now the last one is different because up to this point we've managed to get by with just the 2's and the 6's that we had right here, but this one actually needs a 10, because if you think of 40, 40 is, I mean it's 5 times 8, but that doesn't help because we've got a 5 here, I guess. I guess we could do 10 divided by 2. The easiest way, I think, is to think of this as 10 times 4, or 10 times 2 squared. So this problem becomes, I'll make some space here, this is going to be equal to the log of the quantity 10 times 2 squared. If I have the log of a product, just like I have up here, it becomes the sum of the logs. So this turns into the log of 10 plus the log of 2 to the second. And then this one, remember, I can bring the exponent in front. So this becomes log 10 plus 2 log 2. And log 10, this is, remember, log log by itself means just log base 10. So log base 10 of 10 is 1 plus 2 times, and then the log of 2, back up here, froze again. Log of 2 right back up here is x. So we end up with 1 plus 2x, and that's the finish of that one.